Okay, we can start. I want to introduce Professor Enrico Grosso from the University of Sassari. Enrico Grosso received the degree in electronic engineering in 1988 from the University of Genoa in computer science and electronic engineering, and at the moment is a professor at the University of Sassari, and the main research are on image analysis, pattern recognition, biological artificial vision, visual motor coordination, robotics and biometrics. He's involved in several European projects and local projects, often leading the group, and for several kinds of different topics. And today he will talk about face analysis from similarity to identity. Okay?
Thank you very much. Thank you very much for this so kind introduction. As you see, here you see my name, but what I'm going to present is a sort of cooperative work of many people. So here and there in the slides we find names, exact names of people who have cooperated to this work. Okay, just before beginning, let me spend a few words about the place where we are. Probably you know where is Sardinia. Sardinia is a small island in the middle of the Mediterranean Sea. University of Sassari is in the north part of Sardinia, and the lab where we are working is in the middle of a natural park. There is nothing else than the blue of the sea and the green of the land, and then some buildings, few buildings for 50 people, more or less 50, 60 people. You can say, well, it's impossible working in a place like that. In fact, it is difficult, but it is also so beautiful. Have time to think and, you know, be in perfect balance with the nature. I like this state, and this is the reason why I decided to go there instead of other places in Italy or elsewhere. Okay, we are a very small group, let's say 10 people in total, so a very small group. Two professors, myself and Massimo Tistarelli. A number of researchers. In Italy we have permanent positions and non-permanent positions, so we have 3 permanent and 2 non-permanent. They are on the track, but they have to be confirmed. And we usually have 3 to 4 to 5 people coming from outside, visiting for a couple of months, or 6 months, or 1 year, making some postdoc work, or also during the PhD. So, if you are interested, just let me know, and I will give you more information. We essentially we do basic research on image processing and image and pattern classification. And recently, when I say recently, it means last 10 years, we started with biometrics. But we also do some specific applied research with small and big companies, of Italian companies mainly, also of the mainland. And in this case, we work mainly on visual surveillance, on face recognition and fingerprint recognition. These are the main, let's say, industrial topics that we cover. And last, but not least, we are organizing since 2004, so it's now 14 years, a pretty nice event. It is a summer school on biometrics. It is organized by myself and Massimo Tistarelli. It's a very nice occasion, 1 full week to learn more about biometrics, to have the opportunity to meet big names of this field, to have the opportunity to discuss about topics, and we have usually 10 to 15 speakers, very good speakers coming from outside. It's a very nice occasion. It is in June, end of June, usually mid-end of June. Also in this case, the line is passed, but if you are interested, just ask me and I will drive you in survey. I can do that. So, coming back at the main topic of this short talk. The first statement that I would like to share with you is the following. Face analysis is difficult. You should say, well, it's trivial. But it is not, because for humans, face analysis is simple. While for computers, face analysis is very difficult. So it is not, it cannot be image processing, as we usually target this name, this program. It cannot be even the simple extraction of meaningful information. Face analysis is something more. It involves intelligence, let's say, it involves reasoning, it involves the connection of many high-level things, and it is for this reason that face analysis can be really part of what we call image understanding, or computer vision, as you like. So before saying that this image is Isaac Newton, represents Isaac Newton, it takes a lot of effort for a computer. A person working in the field for many years, probably some of you met him, John Zoltzos, is working in Canada, gave us a very nice, but also very complex definition of image understanding. Face analysis is image understanding, okay, but what is image understanding? He says, oh, given a goal or a reason for looking at a particular scene, a system should produce descriptions of the scene and models and what the image represents. Very complex. Very complex. Let me say the easy way. Image understanding is when we want to use cameras, images, to reproduce the abilities of the human visual system. We have this as, a comparison. The human visual system. And each time we want to reproduce these abilities, we are talking about image understanding. Okay, face analysis is understanding. This is the first statement. The next statement is understanding what? And I'm sure everybody has his own interpretation. Most of you probably say is understanding the digital identity of a person. So I talked about face analysis, but you understand face recognition. I want to recognize that Enrico Grosso, this face, is my face, right? And in fact, this is the main goal of face analysis, recognizing the digital identity. And it is really important to remind that this problem could be a breakthrough in the next future, and probably is very close to us. There are companies, like this one, it's called BioID, it's a German company, selling a way to completely take out your personal identification numbers, your codes, your passwords, your keys, everything you use to access your banking account, or specific areas of your university. So there are people working hard on that, and this is the real near future. I can foresee, let's say, 2-3 years, this will be a reality. But at the same time, we have to say that face analysis is can be something more, much more. For example, discover emotions. or understand expressions. Also in this field, there are many people working hard, and first results are coming out. And this could probably simplify a lot the global field of man-machine interaction. But in my opinion, so I'm just expressing my personal experience, this will be after the first I present. It is coming, but not so rapidly. Probably, let's say, 5 to 10 years. It will take more time. It will take more time. Okay, let me come back to face recognition strictly. So speaking about face recognition, and just note that we use face recognition as a generic term, but face recognition, it is not a single thing. For example, we can talk about face verification, which means that you declare your identity to the system. I am Enrico Grosso, I want to enter in this place. This is face verification, and it is one-to-one matching, very easy for computers, very easy. On the other hand, there is face identification, what we call face identification, which means that you want to enter in a reserved area, you don't declare your identity, but you have the right to enter in there. And the system must understand if this face is part of a small or large database of people having the right passes in this area. In this case, we talk about face identification, one-to-n. But this is very often using just for testing. The real case is the last one. And it is called technically the watch list. A watch list is a one-to-n test where it is possible to find impostors. So it is possible that I go to the system and I say, I am Enrico Grosso, but I'm not Enrico Grosso. And the system should recognize that I'm not present in the list, in the set of templates that grant to access to the area. What we can say about this area of face recognition for things that so far have been studied, investigated, from results that so far have been distributed to the community. We can say that there are simple and difficult things. For example, pose can be managed, but it is not too easy to be managed. Aging can be managed quite easily, especially if the temporal span is not too large. While illumination or other cues, for example occlusions that I can put in front of the face, are in general difficult. But in this case, we are in fact dealing with people that are not cooperating with the system. So it is clear that if I want to enter into a reserved zone, I have to cooperate a little bit. On the other hand, there is a full area, subfield of the image recognition and the face recognition field devoted to what we call faces on the wild. That means that this aspect, recognizing a person in the metro station, on the railway station, on the airport, without any control, it is seen as a very important area of research. But again, it is difficult. It's not when you have a subject who do not cooperate, it's difficult. So, I decided for today to take this problem in general from a little bit different perspective. It is clear that face recognition reached some results. But my question as a scientist is, maybe there are additional problems, additional questions that should be investigated. And maybe that these additional questions apparently are not so close to the face recognition problem. But on the other hand, it is true that they can be very close to the problem. So maybe that we can take a little bit of care to these questions and then come back and see what happens for the recognition of faces. So I would stay mainly on two questions. The first concerns the human visual system. I will show you a little bit more about the human visual systems and the findings that have been introduced into the models to mimic the human visual system. And the second part is more related to psychology, because also findings from psychologists have been used to better design systems that recognize faces. So I will take care of these two aspects. Let me start from the first. How do humans perform? Well, and so that before, humans perform very well. Since the beginning, they perform very well in recognizing faces. And there are parts of the temporal lobe that are devoted to specific problems of memory and faces. I put probably you know that. This area, which is not the part that we usually consider for vision, which is the cortical occipital lobe, right? So the idea is that performs very well, but why? Maybe that there is a mass of computing units, a lot of neurons. So we compute, you perform well because there is a very big power, computational power. It is not so true. It is not so true. If you see these two images, technically speaking, you have a lot of information here, and you have less information here, much less information. But your perception is better here. You can check it, right? Much better. So it's more a question of spatial distribution of the information and how we process this information. And in fact, I like this old picture of Richard Gregory, an old professor that I had the opportunity to meet a couple of things with always very nice discussions. And in fact, all the findings in the area of the retina, on the presence of receptive fields, and on the fact that these receptive fields have different sizes going from the center to the surround, is something that we all know. And we also know that these receptive fields, depending on the area of the cortex involved, can have different sizes. It's a sort of pyramid. You can have very big, less big, and very small. In the same place, they mix. All these have been studied. And the other thing that has been studied very, very well is the importance of fixations, because we usually perform very rapid saccades. We move eyes very rapidly in various areas of the image, and this movement may include a mix of iconic data, images that we select carefully, and some kind of information about the movement of our eyes. We move eyes, and probably we also have a sort of memory of this movement, of this exploration. And this also has been studied very well, and with astonishing results. For example, one thing that I could not believe when I saw this is that both for learning and recognition, we look at the same places. And as Western population is the red one, you see, we look at the eyes and the mouth. The eyes and the mouth. And also for the sheep, it's the same, right? We don't make too much distinction about animals or humans. While people coming from Eastern cultures, they are looking in the middle. A special culture. The blue is Eastern cultures. They are looking in the middle. And what's interesting is that the same approach, looking only in one point in the middle, is the approach of experts. If you take a person who has a sort of training in looking faces, they look at the center, exactly like Eastern people. So they don't need to look too much around. They just look at the center. This is something to be probably more investigated, but what I wanted to tell you is that almost 20 years ago, I reported here 2 papers I wrote 20 years ago, so I'm really old on that. And this has been investigated very well, right? And also models for recognition, for face recognition as a composition of local fixations has been investigated. And you can easily see this is a pro theta log polar model with the fixation on the left, on the right eye. You can see that these 2 images are these 2 faces. But look how they are similar. There is a difference of the gray level, but they are really similar. And the 2 faces are not the same size. So think about it. It's really nice. It's really nice. This fact of fixating and taking this information makes the possible correlation between images powerful. You get a very deep peak of correlation when you try to identify similar regions. So we are at the point that we can make a first summary of information coming from the observation of the human visual system. Major key points. We know that we have multiple fixations. We know that iconic content can be very important, but still remain important questions. For example, which kind of local features are attracting humans, and at which level the motion of the eyes is important. Is very important, just a little bit, or almost nothing. So existing techniques try to respond to these questions. And I put here a paper of 2006, so 10 years ago, more recent, where this has been investigated just in the field of face recognition. So using point and iconic information and mix these 2 to better recognize images of faces. Okay, on the human visual system we did a lot of work. And what about perception? What about psychology? I approached this problem 3-4 years ago, and I started to see how I started reading papers and reading and trying to better understand what could be the nice thing to take to model better the computational processes. And I noted that there is a real, probably is the only method, or probably the most used for rating the similarity between images. Is a method that is based on the judgment of multiple observers. You put two images there, and you start asking people, okay, do you think in a range from 0 to 1 they are similar? And somebody say 0, 5, 0, 7, 1, 0, etc. And then you ask these many times, and at the end you reach the final result, the average, which is 0.87. By the way, is this correct for these two images? What do you think? No?
Sisters.
Good. They are sisters. They are sisters. But 87 is quite a bit high. Don't you think? I mean, at least for me, it's a bit high. They are not so similar. There is something similar, not at all. Anyway, this is what we obtained from practical experiments. 87 is a real result. It's not, it's not just a number to show a concept. But here, as I am more, an engineer, and I try to reason on ways with this in mind. The first question is, okay, but what are going to compare as humans? Just similarities? Is it true? Is it really true? Maybe we are comparing these similarities. So we are looking about different things, not similar. Or maybe that when we are discussing about how two things are similar, we are really trying to use a matrix. And a matrix is a nightmare, because I know that a matrix is in a matrix space there are rules that should be respected. If I say that this process is driven by a metric, well, there are rules that should be respected in any case. And the third question is, but is it perhaps important, the context? Is it the same to judge 100 faces Caucasian and one face from people coming from the east side? Is it the same, like judging 100 Caucasian with 100 people in a set of 100 people coming from the east or from the Asia? The context can be important. If you have the attitude to judge faces in a shared community, and you find something which is really different for traits, you immediately distinguish this difference. So it's not. The context could be, at least I have to think, that could be important. And so we started to analyze that. We put into play a lot of experiments. We started to analyze all the work of a number of researchers telling us that there is a phase space, and the phase space is based on parameters. And you have to take into account 2, 3 more parameters to judge the difference among phases. For example, here you have a face shape, big or not, and eye size, large or not. And you can compose a number of faces with different traits. But it is clear that if we accept this hypothesis, if we accept this theory, immediately we have to accept that in this metric space, several axioms hold. Because in the metric spaces, axioms hold. And in particular, these are trivial axioms. The symmetry axiom. If I measure A with respect to B, it should be the same measuring B with respect to A. It's the same, right? Or the triangle inequality. If you have two sides of a triangle, distances should be more than, greater than the third side. So I mean, it's obvious that these distances should respect these axioms. And this is true. Well, just try. Look at these two images on the right. And then look at these two. and these two on the right. Can you say that these are similar, more similar or less similar than these two? Anyone? Answer? Announcement? Equally similar? More similar? Less similar?
More similar.
More similar. More similar. Most of the people would say more similar. But this, from the point of view of distance, are exactly the same. Because what matters is that we have these three, and the same is equal, right? And if you go by subtraction, you have the same result. But most of the persons, if you ask this to many persons, they say, well, this is a bit more similar, right? So this is obviously a problem, because this means that we are not just perceiving similarities. That's the proof. We are not just perceiving similarities. And in fact, some studies in the past, in the 80s, 70s and 80s, refused the validity of a metric space. They said, no, no, no. A metric space is impossible for faces. And proposed a sort of mix of common and non-common features that all together will put the final results, the final judgment of similarity. That could be an explanation. But please note that if you violate metric axioms, it becomes a nightmare. And I will show you in a minute why. The same holds for the symmetry axiom. If you have a group of people very similar, and one people coming from a very far country, different traits, and you ask people to judge if this is similar to A to B and B to A, you will get different answers. And the reason is clear. It is that if you are judging in this set, you perceive this as very far from all the others. If you judge starting from here, all those people are equally far. And so you don't have to push too much on the dissimilarity. And this is a negative result, proving that the symmetry axiom does not hold. Okay? So it's incredible, but we have this situation. We have that metric spaces cannot be suitable to represent perceived similarity. That's clear. Also, featural models are very questionable because we don't know, we don't have a way to select relevant features. We don't know how to select one feature rather than the other feature. It is clear that the population context is important, but all traditional rating methods that we can find in the literature assume metric spaces and do not account for context. So you see tons of papers, they don't take into account the context. They don't take into account that the metric space is valid or not. They simply give results. Tons of papers and, and research results. Okay, why I'm saying that this is not trivial? I'm saying that this is not trivial because if you lose the idea of a metric space, what happens is that if you have three people and you introduce a new person in your set, you can't rate all the persons in a common rating environment. That is, you put this into play and all the previous rating is lost. And this means that what we are doing, or what many people are doing on that, can be wrong, right? Or at least can be a little bit dangerous, in the sense that they are approximating a lot. And so we try to move forward. We try to move forward, moving from traditional rating to new methods for rating. And we designed a brand new experiment involving almost 300 people, students, mostly students in various areas of our university. And we designed this experiment this way. You put 3 images instead of 2, and you ask the observer to judge if the left is more similar to the center than the right person. So the answer is simply left or right. It's binary. Much easier. You don't ask a grading. You don't ask to say how much is similar. You simply ask, is this or is this more similar to the central one? And we performed this experiment with more than 4,000 sessions. It was a number. We spent almost 1 year to do that. And finally, starting from this answer and starting from all the set of answers, we arrived to build up a new similarity index, which is not the previous a rating. It is an index which takes into account all the set of comparisons. And when we arrived at this end, we put into play a new experiment to validate this, and we asked a different set of people, brand new, without any knowledge, to tell us if this was correct or not, and this is what we obtained. Here you see the difference between this and this, the similarity here and here. It is a number that can go from -1 to 1, because this can go from 0 to 1, and then you get this from -1 to 1. And here you see the answer, and you see that there is a clear behavior. That is, each time this is judged more similar, a different set of observers will prefer the left one, right? So it's in perfect accordance to what we expected. And we did also one more thing, very interesting. We, again, with a different set of observers, asked to judge the same, but with the previous method, the traditional rating. So asking the same question and starting from the previous rating, this was the plot. Previous, after. Previous, you see, after. You see how it spans all the values. It is more precise. It is difficult to show that it is more precise, but it is. And this final plot shows that with our methods, I don't want to enter too much in detail, then we put the title of the paper. It's a paper here in 2015. You see that this is the number of discordant judgment is always lower. So, in fact, this way to rate similarity is better than the previous one, right? So you could say, well, it's a little bit advanced. It's not too much. Always you see that there is a behavior, there is a corresponding slope. Is more or less is the same, but it is not. Because doing that, we found a very interesting additional result that is still unpublished. We will go through in the next months. That is, if you look at this picture, you see the regular behavior of difference of similarity and judgment, rules for left and right. And here in red, you see the behavior you obtain if you consider simply only the triples where one of the two people, left or right, is related by kin. Right? But nobody could know about kinship. So the answer, we have an index of similarity, we repropose the images, and what happens is that even though the difference of similarity is the same, when there is one person related by kinship, something appears, boom, here and here. Not here in the middle, when you don't have differences. But here and here you see this behavior, right? And this is something that, frankly speaking, I cannot still explain completely. We are developing theories to better understand this. But it is clear that there is something related to kinship. And people judging that had no idea about that. They didn't know that two sisters are two sisters, right? But you got immediately. So there is something in our brain, in something that we learn from the past, from our experience, I don't know what, which matters and which enters into play, even though the question is very simple, and it is more similar, or this one. But you judge also about kinship. It's clear. Otherwise, you couldn't get these results. Okay. So I have a few minutes. I rush a bit. All these arguments that I put into the table so far are very useful to better understand what we do as computer scientists. Because if you don't have strong, robust ideas of what people have studied before, it is very different to develop new models. And so far we have two main models that enter into play for face recognition. The first is the holistic area. So you use the whole image. And the second is the feature-based area. That is to want to select precise features. And I don't want to, bore you with a number of techniques that have been developed. I will give you the slides and you will be able to find the main techniques that have been developed. Most of these techniques are based on holistic methods, but other techniques are based on, very interesting, are based on features. And they measure various things of the face, distances, position of points, or they put graphs on the face trying to understand what happens, and so on, and so forth, and so on. Is there any advantage using holistic rather than feature-based methods? Oh, in my experience, the holistic approaches are a little bit computationally expensive, always, no matter which technique you are going to consider. They are computationally expensive. And there is a thing that is disturbing me. That is that very often you don't understand why they get the result. So holistic method work, but you don't really get the reason why they work so well in real number of cases. On the other hand, feature-based approaches can be really robust to variations, can be very compact in the representation of face, and can be computationally efficient. But a main problem remains, which is what kind of features we are going to extract. Okay, I mean, the main problem is extracting features. Which kind of feature can you use to obtain your results? And here I just, one more minute and I finished. I put here a pipeline of the regular processing we do in the lab. And you see that if you get feature-based models, leaving apart the face detection and tracking, you have these two, detection of points and description of the region around each point you extract, and then the matching. But there is something which is missing, certainly, also from what we have seen so far. And what is missing is that it is really difficult to take into account the relationship among points. At least you can do that mathematically. But this is not satisfactory, because when you move, when you talk, when you go around, your face is flexible. So if you simply put a mathematical formula to stretch the points, you don't get good results. And it is for this reason that I will go through. We are now proposing a final approach, new approach, which is based on a mix between 2D and 3D. And in this approach, you get 2D to extract points, but you use 3D to validate points. That is, to validate the real position in the face and coherent position in the face. And we do that for all the points we extract, selecting among 500 points, maybe only 200 or 100, and just doing the matching with these 100 points instead of all the points that you can extract. This works very well, but this requires a mix between 2 and 3D. So your need is having not only a 2D image, but also a 3D scan of the face you are getting. And the results are very good. In this moment, if you apply this kind of approaches, you get on the FRGC database, which is the one we use almost for all our experiments, and considering the all versus all protocol, that is a test in which you match each person, each face with all the other faces, you get results that you see they reach easily 99, 98%. And what it is interesting, and is my final remark, is that you can change a lot this behavior if you add faces into the gallery. When you do face recognition, you usually have the gallery, so the templates, and the probing, the face that is put into play. And if you, instead of having just one image into the gallery, you get 4 images or 8 images, you see, the result immediately goes up. So probably another interesting point in face recognition is do not stop to a single template, but just collect a few, 5 to 10 templates, and then perform with these templates what you want to perform. Okay, I just concluding. What comments? Which comments? First, face recognition remains a very difficult task. At least for me, that I'm working in this area since 20 years. It's a very difficult task. And one thing that I convinced that I know that I'm not alone, but also that many scientists think differently, is that this cannot be solved by crude categorization. Some of one probably heard about deep learning. Deep learning is the improvement of iconic methods, right? So I just put you 2,000 images and you learn what you have to learn. I don't know why, but you learn, right? I really don't like this aspect, because in my opinion, what it is interesting in my research is to understanding what happens, understanding what matters. If there are aspects that are more important than different aspects. And in any case, developing new computational models requires a careful design of experiments. This is the lesson we learned. It takes a lot of effort. Doing an experiment, a serious experiment on that, takes 6 months at least. And the other thing is that most of the findings coming from low-level studies of the human visual system have been considered, sorry. While this is less true for findings coming from the psychological area. There are results, but they are not so coherent with results from the computer scientist. So perhaps the solution is learn more for humans, as I say here, but be careful. Be careful. I mean, try to use humans as a way to compare, but be careful because humans are extremely adaptive, and this becomes makes the task very difficult. And here I want to leave you a final comment, which is personal, but I believe in that. So I'm sure that will serve at least as a sharing of ideas and knowledge. Be careful when you publish things, because in my last 10 years I saw much more published papers, much less quality. And you know, science is not fast. So I know that we in Italy, we have a lot of pressure. We have to publish every 2 months. Every 2 months, one paper, otherwise we are lost. And they tell you, oh, you have to publish, you have to publish. And you don't know how to publish because you don't have results to publish, but you write a paper and it's gone, okay. But I'm not saying John, but is almost. The problem is that somebody, at least somebody like me, sometimes reads paper carefully. And if you publish a paper and somebody reads a paper and say, okay, this guy, you know. So it's a good thing keeping, you know, balance that and follow this Latin, you know, Latin way of thinking, which is pauca sed matura. It's few, but right. Okay? Thank you.
Any question?
Yep.
Yeah, so my question is about the test, the psychological test that you showed, right? So probably you know that there are people with brain damages that are not able to recognize familiar faces. So did you study also that part? Because I know that could be really maybe informative about this field, right?
Yeah, I know. I read a number of papers on that, but we didn't study that. And I agree with you that it could be quite interesting trying to study this aspect. But as I told you, it's extremely long. It's preparing. I didn't realize that because I was, you know, as a computer scientist, you have one idea, in 3 weeks you implement a program. It's done. In this case, you have one idea, and it takes 3 months to get data, at least, to organize the protocol, and etc. So it's really long. We didn't have too much time for that. But I agree, that's a good point. And it could be an area of research, perfectly reasonable. Yeah.
you talked a bit about how more people are using face recognition for biometrics and security and stuff like that. Do you know what sort of techniques they use to get around the problem of just showing a photograph or showing a video to the camera and using that to
yeah. So you mean fooling the system with a picture
exactly.
or something like that?
Or a model.
Yeah, I mean, there are... actually, you can fool the system. Using a picture, it's quite easy to fool a system based on images. And the reason is that an image is an image. If you get an image, is a perspective representation of the image. So you cannot be wrong. On the other hand, always there are many methods that try to test your being people living, you know, asking you make something, for example, smiling, or or moving in some way. And in this case, it is very difficult. For example, one thing that can be asked is turn left, right, and if you turn left or right, the perspective changes, but the picture does not change. So that could be one way. This is, by the way, the reason why in the recent years we focused on 2+3D.
Yeah.
Because very high security companies in Europe and also in the US told us that they were not interested to simple 2D processing, but they were much more interested in 2+3D. And there are very rapid scans. You can get a 3D scan on the fly. We got a machine doing that. It takes 1/10 of seconds. So I mean, 10 milliseconds to get one 3D shot. And with this, you can hopefully overcome this problem of likeness. Yeah.
Please. Have you tested makeup? Like, there's like some serious transformations you can do stuff. It's like, how would that go? Because it looks, I don't know, like women put stuff and they actually make some shades, so it kind of looks different.
And hair. We did a national project 5 years ago on that. Just on the possibility of fooling the system by using various types of makeup or different ways, and it turns out that it is a nightmare.
Oh.
So it's really difficult. If
you also do this, like
no, the problem is that you not really that. Also makeup, if it is reasonable makeup, it's fine. You can always get a good result. What is incredibly difficult, if you put things, a scarf or things that cover part of the face or beard. Yeah, that's if you have it, it's fine. If you cut it and then you go back. Okay, so in this case it's a little bit difficult. On the other hand, I have to say that this is difficult if you are talking about large databases, because if you are talking about 100 people in the gallery, so 100 people of a company that should enter into the company, it's very easy. Large numbers are a problem, more than 1,000 or 1,000.
And what about the facial expressions? You said that you tried to do some sort of deformation, but those don't really work.
We have, I didn't prepare any slide on that, but we have a very interesting result on that. Concerning if you want to understand the mood of a person, it's quite easy to distinguish between two states. Good state, happy, and not happy, unhappy. And this is quite easy. And we have good results from that. But as soon as you consider an additional number of states, it becomes the classification becomes less precise. In any case, I have to say that these do not compromise the recognition. If you don't, you know, if you don't do something critical, okay, if you just smile or if you just a little bit, you know, sad for some, it does not compromise the recognition, the face recognition.
Okay, thank you.
I'm sorry.
Yes.
I was just interested in the link of security companies, and are there any pressure, or do you know how they will apply what you will come up with? That's my concern. How they will use the data that you will provide, or systems that you will provide for them.
So you, something like privacy or?
Yes.
Okay. Difficult question. I'm not caring too much about that because it's not my field. Okay.
Yeah.
What I know is that there are people pushing in this area, saying that in any case your biometrics is well known around. So you leave fingerprints everywhere. You leave your face in, you know, thousands of cameras around the world, and thinking that you have to protect this is a little bit, you know, a bit overcoming. But I know that, for instance, in Italy there is a very severe law. So you cannot take the picture for more than 7 days or 2 months in exceptional cases. So it's also a problem that should be considered. I agree. It's I don't know. It's something that we have to feel. I mean, for me, it is not important my fingerprint. The importance is that if you take my fingerprint to go into my banking account, so if you use that for getting money, it becomes important. Not as a human. I mean, if my personal identity, I should be able to demonstrate my personal identity always, in any case. But there are people that say that should not be stored in any database all over the world. I have a nice solution to that, if you are interested in. There is a way to destructure this information and make impossible to come back with the original data. So I can get your fingerprint. I put this fingerprint on complex processing, and I completely destructure your information. Becomes data, and nobody can come back with your fingerprint or with your face. But in any case, it's a personal data which is stored somewhere. So who knows that there is this link between you and this data can check this identity. But it's much better probably for a person having, you know, in mind that my personal data can be taken and used somehow. Because if you destructure this data, it becomes simply bytes, bits around that do not have any meaning if you don't know that these bytes are of Enrico Grosso. That should be a partial answer to your.
Yeah, but are security companies actually investing in your project and supporting you in any sense at this point? They're just interested in the final outcomes.
They are interested in putting in the airports passport lines, like in when I arrived yesterday in Bristol, and you know, making fast lines to arrive with your electronic passport and be.
So that is state rather than like private companies or
but they are driving strongly this technology. For instance, Sagem, which is one of the main companies in Europe, is driving terribly this. All the systems in the airports, etc., are, you know, sold with this in mind. So it's really difficult because they say that this technology is what we have, this is what we can sell. They do not accept so easily, you know, problems about security or privacy. I know. It's a problem. It's a problem, and for some people, it's a big problem. It's a question of personal also sensibility, but should be ruled in some way. We have to write law for that. So, yeah.
Okay. Thank you again.